Hello and welcome to this lesson on chapter 19, and the first lesson is on addition rules for outcomes of events. If you want to pop today's date and the title and have a go at the do now task that's on your screen. Hopefully you find these questions relatively straightforward and really just used as a warm-up for probability. So question 1A, a drawer contains 8 pink socks and 2 other socks. What is the probability of picking a pink sock? So this will be 8 out of the 10 that are in the drawer. So 8/10, which will cancel then down to 4/5. Part B, a pencil case contains 2 black pencils and 4 other pencils. What is the probability of picking a black pencil? This will be 2/6 cancelled to 1/3. Part C, a box contains 4 brown balls among a total of 5. What is the probability of picking a brown ball? So that's 4/5. Just be careful of the wording of the question there. Part D, a bag contains 4 red sweets among a total of 8. What is the probability of picking a red sweet? So that's 4/8, which cancels to 1/2. Question 2, find the probability as a fraction in its simplest form for A. The probability of picking the letter E from the word repetition. So this will be 2/10, which cancels to 1/5. A vowel from the letters of quadrilateral. So this is 6/13 and can't be cancelled. Part C, of picking a consonant from the letters of probability. So remember, this is A, E, I, O and U for a consonant. That's completely wrong. Hopefully you've just realised that. So the vowels are A, E, I, O, U. The consonants are everything else. So hopefully you've got 7/11. And part D, what is the probability of picking the letter R from trigonometry? So that's 2/12, which cancels down to 1/6. So chapter 19 then is looking at probability, and our first lesson will be looking at addition rules for outcomes of events. And our success criteria for the next 2 lessons. So our bronze objective is to be able to find a basic probability, which we've just looked at in the do now task. Our silver objective is to think back to chapter 13 and understand and recognise when events are mutually exclusive. We'll also discuss again what exhaustive means. And our gold objective, to be able to work out the probability of combined events. So remember back to chapter 13 then, we looked at mutually exclusive and exhaustive events. So if you want to copy down the following definitions as a recap. So mutually exclusive events are those that cannot happen at the same time. And exhaustive simply means that all of the possible options have been covered. So if you were rolling a dice, with a fair dice numbered 1 to 6, but you were only looking at the events of rolling a 1, 2, 3 or 4, this wouldn't be exhaustive because it doesn't look at rolling a 5 or a 6. So exhaustive means it has to cover all of the events. Make sure you have paused the video and copied down the sentences. So let's have a look at a bit of an activity on mutually exclusive and exhaustive events. So for each scenario in question 1, can you say whether the pairs of events are mutually exclusive or not? So are they mutually exclusive? You might want to tick or say yes, or if they're not, put a cross and say no. Make a note of these in your exercise book before you listen to the answers. So for part A, tossing a head with a coin and tossing a tail with a coin. Well, yes, these are mutually exclusive because they cannot happen at the same time when you are tossing a coin in one go. So in one go, you cannot get a head and a tail at the same time. Hence, these 2 events, these 2 scenarios are mutually exclusive. Part B, throwing a number less than 3 with a dice. Throwing a number greater than 3 with a dice. Again, these can't happen at the same time. The number's either less than 3 or it's greater than 3, so they are mutually exclusive. Part C, drawing a spade from a pack of cards and drawing an ace from a pack of cards. Well, these are not mutually exclusive because they can happen at the same time, as you can, of course, pick out the ace of spades. Part D, drawing a spade from a pack of cards and drawing a red from a pack of cards. Well, these are mutually exclusive because we know that the spade cards are the black cards, so you cannot pick a spade and a red at the same time. Part E, choosing from a group of 3 girls and 2 boys. At the same time, can you choose 2 girls and choose 2 boys? Well, yes, you can, because there were 3 girls and 2 boys, so this can happen at the same time, so they are not mutually exclusive. Drawing a red card from a pack of cards or drawing a black card from a pack of cards. Well, yes, these certainly are mutually exclusive because they cannot happen at the same time. Part G, winning a football match and drawing a football match. So these cannot happen at the same time, so they are mutually exclusive. And Part H, eating toast for breakfast, eating chips for dinner. Well, these can happen at the same time, so they are not mutually exclusive. Question number 2. Which of the pairs of mutually exclusive events in question 1 are also exhaustive? So we're looking at A, B, D, F and G. So which ones cover all the options? Now if we look at A, tossing a head with a coin and tossing a tail, there are no other outcomes from tossing a coin. So part A is exhaustive, it covers all the options. Part B, throwing a number less than 3 or a number greater than 3. Well, this doesn't include actually throwing 3. So B is not exhaustive, it doesn't cover all options. Part D, drawing a spade from a pack of cards and drawing a red card. Well, this doesn't cover all options either. It covers all the red cards, but clearly not all of the black ones, because you have clubs as well. Part F, drawing a red from a pack of cards, drawing a black from a pack of cards. Well, yes, that covers all of the options of the cards, so F is also exhaustive. And Part G, winning a football match or drawing a football match. Well, obviously this doesn't take into account the scenario of losing the football match, so this Part G is not exhaustive. So we have used the addition rule already back in chapter 13, but we didn't formally define it. So when 2 outcomes are mutually exclusive, so when they cannot happen at the same time, you can work out the probability of either of them occurring by adding up the separate probabilities. And this is formally known as the OR rule of probability. So it's the probability of something or something else happening, and we add the probabilities together. But please bear in mind, the events need to be mutually exclusive. So let's have a look at an example. A bag contains 12 red balls, 8 green balls, 5 blue balls and 15 black balls. A ball is drawn at random. What is the probability of it being A red, B black, C red or black, D not green, E neither green nor blue? If you want to pause and have a go before I reveal the answers. So for part A, the probability of it being red was 12/40ths, which will cancel down to 3/10. Probability of it being black is 15/40ths, which cancels to 3/8. So for red or black then, you work out the probability of red, the probability of black, and you add them together. So this will be 3/10 plus 3/8, which is 27/40ths. Now you can get a common denominator and add them, or you can use your calculator if you wish. Part D, not green. Remember, not green will be 1 take away the probability of it being green, or just add all of the other ones together. So that's 32/40ths, which cancels to 4/5. Now neither green nor blue. Now neither green nor blue would mean that it would have to be red or black. So you would add together the red and the black, and you should get 27/40ths. Now be careful, you cannot work out the probability of it not being green and not being blue and then add them together, because not green and not blue are not mutually exclusive, because not green includes blue and not blue includes green. So the addition rule wouldn't work here. So for neither green nor blue, you would need to look at the other options and then add them together. Now on to exercise 19A. So the exercise is quite straightforward. I'm going to work through question 1 with you and then leave you to do the rest, and the answers are at the end of the PowerPoint. You then have a second lesson to do this week and then a number of Hegarty tasks to complete. So question 1, Jenny picks a card from a standard pack of playing cards. What is the probability that she picks A heart? Now remember, in a standard pack of playing cards there are 52 cards. 13 hearts, 13 diamonds, 13 spades and 13 clubs. If you're unsure of this, it might be an idea to go away and do a little bit of research on what a pack of playing cards consists of. So the probability of picking a heart, there are 13 hearts out of 52. This cancels to a quarter of the cards. B, a club, again there are 13 out of the 52 cards, which would cancel to a quarter. So a heart or a club, we add these two together. So a quarter plus a quarter is 2 quarters, which cancels down to a half. Now have a go at the rest of the exercise in your book. When you are ready to mark your work, the answers are all here in yellow. And now we can have a go at some true or false questions. So mutually exclusive events cannot happen at the same time. This is true from our definition earlier. Exhaustive events cover all possible outcomes. Again, yes, this is true. The addition rule finds the probability of an event A and an event B happening. No, this is false. The addition rule finds the probability of an event A or an event B happening. Yes, this is true. The addition part comes in as we add them together. The addition rule can only be applied to mutually exclusive events. Yes, this is true.